It's coming. I can see it on here, so that's good. Yeah. Afternoon, everyone, and thank you to the Italians for providing the weather for us Northern Europeans so that we feel at home. Okay. My name's Roman's already done the introductions. You know who I am. I want to talk to you about combining developer interest to access offshore carbon sites, in particular the issues with other seabed uses. I guess I just page down as I use this button, or is it on there? No, it should be full screen. That's right.
Like,
That's fine. Yeah, click on that. Great. I've got three messages today, right? So it'll be nice and hopefully straightforward. Before I start, I've had lots of questions about what is the Crown Estate and what relation does it have to the UK regulatory authorities, etc. The Crown Estate basically is the seabed owner and the subsurface owner. So it manages the rights on behalf of the country and the money goes back into the UK Treasury. The two parts of our main messaging there that I've highlighted are return the profits to the Treasury, but also to manage the land and seabed in a way that is sustainable for the future. So the three messages, and these slides will be made available afterwards. First of all, about net zero and the need for the use of the marine space to achieve that, both reducing carbon emissions, which is all about emissions and geology, and also for providing renewable energy. And in this case, I'm going to talk about offshore wind. And obviously, wind yield is key to the placement of that. I'll come on to that in a moment. And also geology. Different geology, shallower, but it all interrelates. Then I want to talk a bit about the remedies, about making both of those sectors play nicely together, as I call it, in the same space. And then come on to the kind of actions that we are undertaking, not just the Crown Estate, but a whole range of bodies in the UK across government, the trade bodies from both sides of things, both sectors, etc. Marine spatial management. This is really where we earn our money. The Crown Estate sees all the use of offshore sectors, whether it's aggregates, telecoms, cables, wind, carbon storage, transmission lines, interconnectors, etc. All of that crosses the seabed, and it's incredibly important to everyone, and it needs to be managed in a sustainable, practical way. The way we're used to as subsurface professionals, and I put myself back into that camp because I'm kind of bridging into government nowadays, is looking at the kind of size and capacity. So we typically see a bubble map like the one on screen that the Department of Energy Security and Net Zero, I'll refer to them as DESNES because it's a bit quicker than that mouthful, the way that they show the size of the stores. But that only tells you about the potential capacity. It doesn't tell you about the footprint associated with them. So we did some work as part of the co-location forum between offshore wind and carbon storage, more of which I'll come to later on, which resulted in these two other maps. And what these show are the emissions, the onshore emissions, the location of those in the first one. The middle one is England, Wales, Northern Ireland, and the right-hand one is Scotland. And also what I've highlighted in the offshore are the carbon storage licenses. And currently the UK has issued 28 licenses for carbon storage appraisal. And also the offshore wind farms, either those existing ones already producing or the ones that are being developed and built at the moment. So you can see, just by looking at those alone, you can see certain sectors of the UK continental shelf are getting quite busy in that sense. If you actually then look at what's really there, this image shows all the things that are actually happening in that space, and includes things like the major shipping routes, etc. It's a very busy thing to manage. Right, so about 3 years ago, when I joined the Crown Estate, just before me, someone had commissioned a report looking at carbon capture, storage, and offshore wind, and what the issues might be with the two coexisting in the same space. And they came up essentially with that diagram on the left-hand side, which shows the kind of issues that are there. Mostly it's to do with collision, to do with monitoring, to do with towed streamer seismic, but also to do with bringing in rigs, whether it's to drill wells or to work over wells. You've got potential collision issues, especially with closely spaced wind turbines. And they did a kind of risk matrix approach on the right-hand side. And that led to the forming of what you can see in the bottom left-hand corner, the offshore wind and CCS Co-location Forum, where we bring all of the relevant players in the UK together to discuss how we best work together and solve the issues associated. And as it shows here, the purpose of the forum is to cover those things. It's also to get the two industries talking to each other, because wind has been tremendously successful in the last 15 to 20 years. After oil and gas was tremendously successful in the UKCS and other parts of the world before that, they haven't really had to play too much in the last few years, but boy, are they going to have to play together now, right? Because we're about to put a lot of carbon stores there. Okay, I've got some slides here that I pinched from my colleague. So these we showed at a recent event that we hosted for both sectors, where we had members from the wind industry and members from the carbon storage industry together to talk through the kind of issues about monitoring and about why a wind farm is where it is. And this slide actually focuses on the Dogger Bank wind farm, which are huge. I think it's the world's biggest at the moment, planned, etc. You can see the gigawatt numbers against the different parts of Dogger Bank shown in the first few bullet points. But then look at the highlights in the bottom, and the color of the maps will change as it changes data. So shallow sea obviously means cheaper wind turbines because you can anchor them to the seabed. That's one thing. Then also, is the wind speed in that area strong enough to give you a good yield? And again, you can see from the red box, the Dogger Bank highlighted, that's in a good wind speed area, also shallow bathymetry. Also, is that sediment stiff enough to be able to put foundations in to hold a massive wind turbine in place? Again, it's good. So that's another reason why it's there. Is the sediment deep enough that that doesn't just rip out when you put it in? Because these things are enormous, right? We all know that they're the size of the Eiffel Tower, etc., and growing, many of them. And then is the weather conditions, i.e. the mean wave height in that area, also feasible for that kind of wind farm? So Dogger Bank scores on all those areas, and it's right slap bang in the key bit of the southern North Sea in the UKCS. So that's why the wind farm's there. Then Mike, my colleague, went on to explain about the layout of the turbines, which is the constant thing that we talk about. Well, if you just space them a bit further apart or put them in a different configuration, it would make it easier for us to get the seismic vessel in. Well, that's not going to happen for a whole host of reasons. This kind of shows, and it's basically summarized on the right-hand side, the kind of reasons for why the turbines are spaced the way they are. Obviously, wind yield is a key part of it. Safety is another part, although it doesn't look like it's the same for all of them. Straight routes to find issues, etc. And then sometimes centralization of the transmission gathering point of the electricity, etc. So wind farms are here to stay. They're here. And we have to work around them. It's basically the message from that. So then some work that wasn't done by the co-location forum, but was done by, you can see on the top right, another task force which is being run as a series of task forces by the North Sea Transition Authority, which is the competent authority in the UK for carbon storage. They have these task forces made up of a lot of industry members, but also the other regulators and bodies involved, including ourselves and including government. They did a project looking at technologies other than 4D seismic, or other than towed streamer 4D repeat 3D seismic for monitoring CO2, and their conclusions, which they've just published in a report, are kind of in this red, amber, green layout. You can see here the type of things. There's obviously 4D gravity is a possibility, 2D seismic, time lapse, distributed acoustic sensing, fiber optics, etc., and surface microseismic, which Phil talked about earlier in the conference. So that's one output, and that's really interesting. On the right-hand side, you can see the 2-track 1, 2-track 2 cluster projects that the UK is building at the moment and where they might get deployed. This is kind of a recommendation, so it's not yet an obligation on those developers, but that's what that's come out of. The next slide spins it a different way and says, with the same set of technologies, which of them in the middle and the fifth column across, which of them make co-location with offshore wind more possible? And many of these do, of course. That's one of the reasons they've been looking at them. But still, best available technology, tendency to do time-lapse 3D seismic. Okay, so let's talk a little about scene setting, a little bit about searching for MMV, and I'm going to go into more of that now about the kinds of things we can do to make these two sectors cooperate better. So you've seen the maps on the first side, the spatial characterization work I've already talked about. On the top right is the seismic work that the Transitional Authority did as part of the forum, looking at different geological characteristics where time-lapse seismic is going to work and where it's not going to work, etc. So that's publicly available too. And we've now got two more projects ongoing. One with the University of Aberdeen looking at where the types of monitoring technology would be suitable given the geology and the conditions of storage that might therefore be compatible with offshore wind. And then another project, Project Anemone, which is just kicking off, which has somewhere between 6 to 10 developers involved. It's a joint industry project with wind companies and carbon storage companies. And the idea there is to get together and discuss best practice in simultaneous operations where the two sectors can work. So kind of above seabed, whereas the other one's below seabed. Sorry, too wordy. Just read the bits that are underlined if you like. The project co-locate essentially is what I've just said. It's looking for where the kind of MMV that will be compatible is going to exist to persuade, as I put at the bottom, to persuade stakeholders that co-location is feasible. That's the key. Technically, a lot of this stuff is perfectly possible, as we know, as we talk about, but it's really just getting to everyone's mindset that this is, yes, something you want to do. Okay, I'm going to skip through a bit more. An enemy I've talked about, that's simultaneous operations. We were suggesting things like this a couple of years ago in the forum. Could we use the wind? Could we use the fiber optics to try and use the detection device? You know, if you've got a wind farm there, maybe that's a good thing. And I think Phil was talking about that earlier. And on the right-hand side, trying to explain to people that don't understand the subsurface, you can drill bendy wells, you can go round things, you don't have to go through your store. Final point, a couple of slides. The kind of actions that we're involved in, the Crown Estate has realised it's got access to a tremendous amount of data about the UK's sectoral use in the offshore, and it's trying to pull all this together with primary areas of opportunity for all the different sectors and try and work out where the good stuff is and how we should try and optimize its use. And then to build that into a series of scenarios, you know, best economic case, least environmental impact, etc., through all the things, and look at a route map to 2050, as we call it. And then it's a case of bringing all these initiatives together. You know, we're one organization in this space in the UK. We obviously want to share this with other countries, but within the UK, there's lots of other initiatives. You know, there's one covering different geographies of the UK. There's ongoing task forces and forums and initiatives covering land versus sea. And then there's multiple different sectors, you know, whether it's about energy security or whether it's about carbon storage or about renewable targets, etc. There's lots of things operating in this space. What the Co-location Forum is trying to do is not reinvent stuff and try and pull some of this stuff together and then share stuff going the other way as well. And last slide, that's kind of the bottom line output on co-location. We either continue to avoid each other, keep the wind farms and the carbon stores apart, which is tricky, has been done in some instances, but is not the only way forward. Or we solve it. We find ways that the two are compatible, which I've mentioned a few of, or we have some compromise somewhere in the middle, kind of obvious. I think that's me.